So this is the 11th NCRT. We have already completed 6 to 10th NCRT. We are just left with the NCRT of class 11th and 12th. So there are 2 NCRTs each in each class. So we have 4 more books to study. So we'll be jumping to the unit 2 of the class 11th NCRT. And the title of the chapter is Origin and Evolution of the Earth. Okay, let us start to this chapter. Okay, origin and evolution of the earth. So in this chapter we will be studying about how earth got originated. Not only earth, we will studying about the origin of the universe. Okay, let us start discussing. So in the first uh, page itself of the chapter second, they have discussed about the contribution of Laplace. So try to remember this name, Laplace. Okay. So Laplace and nebular hypothesis. This type of questions are asked. So write it down in your notebook about this. Okay. Laplace, he has given nebular hypothesis. Nebular hypothesis. So this type of questions have already been asked. Okay. Let me check who is there. So Havila, welcome to the class. If you have any question, you can ask. Okay. So
Okay,
we are discussing about the class 11th NCRT, and we are studying about the origin of universe. So I have given one name of the scientist which can be asked, the Laplace, as okay, which has given the theory of nebular hypothesis. We'll copy it and paste. Okay, it's not there. Somehow it's unable to copy. Let it be. So the nebular hypothesis, which is given by the Laplace. So you should write it down in your notebook. The hypothesis considered that the planets were formed out of the clouds of material associated with the sun. So in the nebular hypothesis, I am writing in the nebular hypothesis. Okay, the nebular hypothesis, it was given by Laplace. Okay, it was said that the planets formed were formed out of clouds. Okay, so earlier there were clouds now formed of the dust, so that the clouds transformed itself to form different planets around the sun. Okay, let us say this is sun. So around the sun you got different types of planets. Okay, this is what the nebular hypothesis suggests, that the planets were formed out of the clouds. That was given by Laplace. So if the question will be like Laplace and nebular hypothesis, that is what you need to understand. Again, for you, the modern theory, which is called as Big Bang theory. You know about the Big Bang theory, right? You have studied the Big Bang theory, which is also called as the expanding universe hypothesis. It is expanding universe hypothesis. I will explain you what this theory suggests. Okay, let us say this is the balloon you have. Okay, now when you are putting air into it, So the balloon becomes big. Okay. Okay. So the size of the balloon. Okay. So these are the dots in the balloon. Let us say these are 5 dots. So you will see the size of the dots also increase like this. Okay. This is what is called as expanding universe theory. Expanding, expanding universe theory. So which is also called as Big Bang theory. Okay, also called as Big Bang. Okay, so it is called as the Big Bang theory, and this is one of the most accepted theories in the world. Is it clear? Look at it. Look at the diagram carefully. Here I have drawn one diagram, one balloon, which is smaller in size. Even the size of the planets inside it is also small. But as I push air into it, I'm pushing the air into it. So the size of the balloon is increasing, and the size of balloon, not only balloon, but also these dots is also increasing. Look at this, right? You see the size of each individual dot in it has also increased. So this is what the this is what the expanding universe theory is. That it means the universe is expanding. Okay, is it clear? So this is what expanding universe theory suggests. Okay, look, I have given an example of this. Take a balloon and mark point. I have explained it. Okay, so now we will be discussing about the singularity. Okay, here you have the concept of singularity. So we will be discussing about what singularity is. Okay, so we will be discussing about the singularity. Look, what does it indicate? So earlier it is said that you had a single point. Okay, look here, at the beginning, at the beginning of the universe, all matters forming the universe existed in one place in modern forms of a tiny ball, that is a singular atom. Okay, you have a tiny ball which is singular atom. Is it clear? Okay, with unimaginably small volume, infinite temperature, infinite temperature, okay, and infinite density. Okay, so these three things are there. Are you getting it? In the singular atom like this, here you can look in the diagram. This is the singular atom I'm talking about. At the Big Bang, the tiny ball exploded violently. This led to the huge expansion. So expansion is shown. Look here, the expansion is shown. Okay, now generally accepted that the Big Bang event took almost 13.7 billion years ago. 1370 करोड़ साल पहले ये सब चीजें हुई है, ऐसा साइंटिस्ट बोलते हैं. द एक्सपांशन कंटिन्यूज इवन टुडे. ऐसा बोला जाता है कि यूनिवर्स आज भी एक्सपांड हो रहा है, मतलब स्टेबल नहीं है. जितना हमको दिखता है वो तो 0.001% भी नहीं है. एंड अपने आंखों को सिर्फ 5% एनर्जी दिखती है. 95% ऑफ द एनर्जी विच इज कॉल्ड एज डार्क एनर्जी और डार्क मैटर विच इज नॉट इवन विजिबल टू अवर आईज. जो हमको दिखता नहीं वो 95% चीजें है. आई एम नॉट टॉकिंग इनसाइड द ऑन द अर्थ, आई एम टॉकिंग इन द यूनिवर्स. ओके, so there was particularly rapid expansion within the fraction of seconds after the bang. जब वो चीज हो गई, जब यूनिवर्स का एक फ्रैक्शन ऑफ सेकंड में वो एक्सप्लोड हुआ, तो बहुत फास्ट रिएक्शंस होने लगे. Thereafter the expansion slowed, or afterwards the speed of the expansion slowed down. Okay, within 3 lakh years, the Big Bang, the temperature dropped to 4500 Kelvin. Okay, तो टेम्परेचर ड्रॉप होने लगा क्योंकि अर्लियर तो इनफाइनाइट टेम्परेचर था, राइट? इनफाइनाइट टेम्परेचर आई हैव रिटन हियर. लुक एट द सेकंड पॉइंट. और बाद में थर्ड पॉइंट के अंदर यूनिवर्स ट्रांसपेरेंट बनने लगा. द एक्सपेंशन ऑफ द यूनिवर्स मींस इंक्रीज इन द स्पेस बिटवीन गैलेक्सीज. हियर गैलेक्सीज आर शोन. लुक, दिस इज in the diagram on your right hand side. You can see my tick marks. This is one galaxy, this is another, this is another. Look at the distance. Look at the distance between these four galaxies. Afterwards the distance has increased continuously, right? So we live in one of the galaxies, and that is called as Milky Way galaxy, or in Marathi that is called as Akash Ganga. Okay, is it clear? So this was the Big Bang for you. Now let us start discussing how stars were formed. The distribution of the matter and the energy was not evenly in the early universe. The initial density differences give rise to differences in the gravitational forces. It caused a matter to drawn together. This formed the basis of the development of galaxies. So if the question comes, what is the base of the development of galaxies? That it is the difference between the density. Difference between the density is that it leads to the different gravity, because gravity, the formula of gravity is gm m1 m2 divided by r square. So where density will be dependent upon the mass, right? The more is the mass, more is the density, right? So that led to the formation of gravitational force. The galaxy contains large number of stars. So in single galaxy, let us say for example in Milky Way galaxy, you have hundreds and thousands and crores of stars are there, and each star you have a lot many planets also revolving around that. Like in solar system we have 8 stars. You know what is light year? You know what is the difference? Light year, the question was asked. Okay, light year is the measurement of distance and not time. Okay, light year measures the distance and not the time. Light travels at the speed of 3 lakh किलोमीटर per second. लाइट की स्पीड कितनी होती है? 1 सेकंड के अंदर लाइट जो है 3 लाख किलोमीटर दूर जाती है. ओके, the distance the light will take in 1 year to be 1 light year is equal to 4.9 to 10 raised to 12 किलोमीटर. अब आप डिफाइन करो कितना ज्यादा है. This means the distance between the sun and the light is almost 15 करोड़ किलोमीटर. तो सूरज और अर्थ के अंदर का जो डिस्टेंस है वो 15 करोड़ किलोमीटर है. ओके, और ये 15 करोड़ किलोमीटर है, इसीलिए उसको 8.3 मिनट्स लगते हैं सनरेज को पहुंचने के लिए. So that was the formation of stars. And now formation of planets. Following are considered to be the stages in the development of planets. Stars are localized lumps of gas within nebula. Okay, nebula के अंदर जो light localized lumps of gas होते हैं उसको stars बोलते हैं. Gravitational force within the lumps leads to the formation of core of the gas and huge rotating disk, and that leads to the formation of what we can say as the planets. The gas clouds, look, the gas clouds starts getting condensed, जमा होना शुरू हो जाता है clouds का, और वो फिर planets बना देता है. Okay, small and rounded objects देखो, आसमान में की ज्यादातर चीजें गोल होती है, याद रखना, बिकॉज उसको फ्रिक्शन अवॉइड करना होता है। ओके, फ्रिक्शन अवॉइड होता है जब आपका राउंड शेप होता है। यू लुक एट द टायर्स, राइट? जब आप टायर की भी चीजें देखते हो तो आपको वो दिखते हैं राउंड शेप की, बिकॉज राउंड शेप गिव्स यू मिनिमम फ्रिक्शन। फ्रिक्शन, इज इट क्लियर? Okay, now we will look how our solar system is formed. We have 9 planets. It is said that, but we consider that the Pluto to be the dwarf planet, and we actually have the 4 planets, 8 planets only. You know what is the difference between inner planets and outer planets? Inner planets are the 4 planets which are located within the asteroid belt, and the stars which are the planets which are outside the asteroid belt are called as outer planets. Okay, so the first 4 planets are also called as terrestrial, like, because terrestrial, why? Because they look like earth, that's why they are called as terrestrial planets. The first 4 planets, which will be Mercury, Venus, Earth and Mars, these 4 planets are called as terrestrial planets, or they are also called as the inner planets. Okay, and Jupiter, Saturn, Uranus, Neptune, these 4 planets are also called as outer planets. Okay, remember what is inner and what is outer. And outer planets are also called as Jovian planets. Remember this name, outer planets. Look, this is called as inner, this is called as outer. Okay, terrestrial planets were formed in the close vicinity. It means the proximity. Proximity means closeness. Okay, they are formed very close to the parent star, that is sun. ये जो पहले 4 चीजें हैं, look at the diagram, then only you will understand. I will draw, there is no diagram here. And this type of questions will be asked. Let us say this is the sun, so you have here Mercury, then you will have Venus, right? Then Earth, and then Mars, right? This, then you will have the asteroid belt, and then you will have Jupiter, then you will have Saturn, stars like that. So these stars are called terrestrial or inner, and these stars are called as Jovian or outer. Okay, this is how it will look. Now the terrestrial planets were formed in vicinity, that is closeness or proximity to the sun, where it was too warm for the gases to condense to solid particles. Jovian planets were formed at the quite distance, at the quite distant location away from the sun. The solar winds was most intense near to sun, so it blew off lot of gas and dust from the terrestrial planets. Okay, the solar winds was most intense near to the sun, so it blew off the gases and dust from the terrestrial planets. The solar winds were not all that intense to cause the removal of gases from the Jovian planets. So you have gases in the Jovian planets, and you don't have any gases or atmosphere in the terrestrial planets. And terrestrial planets are smaller, and uh, their lower gravity could not hold the escaping gases. Also, they have less gravity because they have less mass. So we'll be discussing about the evolution of Earth now. Okay, this point, how our planet, that is Earth, evolved. Evolution of the Earth. Do you know that the planet Earth initially was a barren, rocky, and hot object within a thin atmosphere of hydrogen and helium? It means that earlier we only had hydrogen and helium. Okay, this is far from the present day picture of the Earth. Hence, there must have been some events which led to the change in the situation of Earth. So now Earth has a layered structure, troposphere, stratosphere, mesosphere, thermosphere, that type of structure. Earlier, it was not the case. Development of lithosphere, how lithosphere got developed. The Earth was mostly in the volatile state during the primordial state. Due to gradual increase in the density, the temperature inside the Earth increased. As a result, material inside started getting separated depending on their densities. This allowed heavier materials like iron to sink towards the center. That's why at the core you have knife, right? Knife, that is nickel and ferrous. Yes. So you have nickel and ferrous because the more the density, the lower you will go. This allowed the heavier materials like iron to sink towards the center of the earth and higher ones to move towards the surface. With the passage of time, it cooled further and solidified and condensed into smaller size. This latter led to the development of outer surface of the in the form of crust. It is which is only 5%. Crust is only 5%. Remember that. During the formation of moon, due to giant impact, the earth was further heated up. This it is through the process of differentiation that the earth forming materials got separated into different layers. So you have different layers like crust, mantle, and core. This like crust, mantle, and core. This is due to the differential heating or the differential densities. Evolution of atmosphere. How our atmosphere developed. There are three stages of evolution. The first stage is by loss of primordial atmosphere. Okay, loss of primordial atmosphere. That is the first stage. Okay, and in the second stage, the hot interior of the earth contributed to the evolution of atmosphere and the composition of modified due to photosynthesis. The formation of food by the plant or the autotrophs are through the process of photosynthesis. That due to chlorophyll pigment present in the on the leaves. Okay. During the cooling of earth, earlier, as we all know, earth was very hot. During the cooling of earth, gases and water vapors released from the interior of the earth. Let us say this is the earth, let us say, and from the interior you see the release of gases. So you have nitrogen, carbon dioxide, methane, ammonia, etc. This is called as degassing. Okay, this process is called as degassing. So question can also be asked on this, that eon is greater than era is greater than period is greater than epochs than ages. Okay, so this can be asked. Remember this. that eon is greater than era is greater than period is greater than epoch. Okay, so lot many eras will look, lot many ages will come together to form the epoch, and many epoch will come together to form the period, and many periods will come together to form era, and many era will come together to form eon. So you need to remember this, that eon is greater than era, is greater than period, is greater than epoch. So how you are going to remember, I don't know, but I will suggest you to write it down and remember this. Okay. Origin of life. The last phase in the evolution of Earth relates to the origin and evolution. You know that all survival of fittest and theories, you know all of that. So can you answer this? So which of the following figures represent the age of the Earth? This is not the age of Earth, right? It's not in trillions. This is not the age. And this is also not the age. So 4.6 billion years ago, you see the formation of Earth. So which of the following has the longest duration? Eon. Which of the following is not related to the formation of modification of the atmosphere? Degassing, photosynthesis, all except solar winds. Question is not related. Which of the following represent the inner planets? Between Sun and Earth? No. Between Sun and a belt of asteroid, right? So these are related to the inner planets. Life on Earth appeared how many? Look, life on the Earth appeared around how many years before the present? Okay, it's almost 3.8 million years ago. You can see. Okay, so it can be 3.8 billion. Sorry, so that can be the possible answer. Okay, this type of questions are asked. So we'll jump to the next. That is the interior of Earth. I think uh, you know we have studied the interior of Earth. Yes or no? Let me see if anyone is there. So if you want to continue, I can continue with that. But we have already covered. Some of you just unmute yourself and let me know whether we should continue with the interior of Earth chapter, because I have completed. If you want, I can complete. Havila and Venala can answer. Unmute yourself and let me know. Otherwise, I will just uh, tell you some facts which can be asked. Unmute yourself and ask. I know that you are on your mobile now. You can ask questions. Yes, Vanilla and Havila.
Yes, sir. Continue facts.
Okay. We'll just talk about the facts which can be asked and we'll jump to the next. Okay. Because we have already talked about this while I was there in Hyderabad. I have covered. But Nayan Sarod is also there. So I will uh, just talk in brief and I will then jump to the next. Now here, the deepest drill at the Kola in the Arctic Ocean, the human has gone till the depth of 12 kilometers inside the earth. You just remember this. And this is near the Kola in the Arctic Circle or the Arctic Ocean. And you know, in African continents, In the African continent, you have gold mines which can be 3 to 4 kilometer long or 3 to 4 kilometer deep. So this type of questions are asked. I think NDA can ask what are the indirect sources. Look, there are two types of sources. One is direct, another is indirect. So direct sources and indirect sources can be asked by the government, by the NDA, that what are the indirect sources of knowledge of the interior of the earth. So analysis of the properties of the matter indirectly provide information about the interior. We know through the mining activity that temperature and the pressure increases with the increasing distance from the earth toward the center of earth. Moreover, it is also known that the density of material also increases with depth. We know that, right? It is possible to find the rate of change of these characteristics. Okay. Another source of information are the meteoroids. Okay. Another source is the meteorite. However, it may be noted that the material that becomes available for analysis from meteorites is not from the interior of the earth. The material and the structure observed in the meteorites are similar to that of earth, but not necessarily as the uh, core. Another indirect source includes gravitational, magnetic field, and seismic activities. You know, seismic activities means earthquake related activities. Gravitational force is not the same at different latitudes on the surface. You know, while studying physics, you take different values of the G at the pole and at the equator. So the value of G is greater or lesser at the equator, tell me, compared to pole. At the pole's value is more or less. The value of G, value of gravitational force, it is more at the equator or less at the equator. Nobody knows. I'm asking a simple physics question. The value of gravitational force G is less or more at the equator? Tell me. Less. Somebody is saying that at the equator value of the G is less. Another? Any other response? Go and check. At poles it is high. Okay. It means at the equator it is less. The reading of the gravity at different places is influenced by many factors. Okay. This is called as gravity anomaly. Like we have anomalous behavior of water. So in that sense we have gravity anomaly. Gravity anomalies gives information about the distribution of mass of the material inside the crust. Magnetic survey also provide information about the distribution of magnetic materials in the crustal portion, and thus provide information about the distribution of materials in the part. Seismic activity, that is earthquake related activities, also give example. You know what is focus and what is hypocenter and what is epicenter. All of you know that. What is it? I will not repeat that. So earthquake waves, while teaching earthquake waves, I have taught you about the S waves and P waves, and R waves and L waves. You know that. Look, this image is important. This image is very, very important. Okay. It means that P waves will come first, and after the P waves, you will have S waves. After S waves, you will have surface waves. Okay. So P waves, that is primary waves, will come faster than the S waves and the surface waves. Okay, this type of questions are also asked. You know, the P waves are called as primary waves, which are like the sound waves only, and sound waves are the longitudinal waves. Okay, S waves are called as secondary waves. Okay, and S waves can only pass through solid. S stand for secondary, S stand for solid, and secondary waves only pass through solid. You can remember that. It is as simple as that. So this image again plays very important role. Okay, this shadow, so 103 to 101 40, this 142 almost 40 degrees angle, which is the P wave shadow zone. In this area, you will not see any impact of P waves. So that is called as P shadow zone, P waves shadow zone. Now again, another important thing is Richter scale and Mercalli scale. Okay, the magnitude scale is called as Richter scale. Remember this. Magnitude scale is called as Richter scale. The magnitude relates to the energy. Okay, so I will write it here, magnitude, which is measured in the Richter and it measures the energy. Okay, and this is in the form of 0 to 10. So 4 points we got. Then we have intensity. I will write with the different pen. Intensity, okay, is measured in the Mercalli, which takes into it's taken to account the damage. Okay, it's 1 to 12. Now look, you need to understand this and remember that magnitude is measured in the Richter scale. Okay, uh, it means we are counting the energy from 0 to 10, and intensity, that is the damage, is caused is measured in the Mercalli scale, which measures from 1 to 12. The, look, this is how it will. If I draw a scale, so let us say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be the magnitude. It will be magnitude, right? It will be Richter, right? Then this will be 0 to 10. Okay, and it will measure the energy. And another you will have is the intensity, which will be measured in Mercalli, which will measure the damage, and which will measure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will be 0 to 12. So this is how the images will be seen, different scales. Okay. You know effects of earthquake. You know what is earthquake is? It is the shaking and trembling of earth. You know that. And there are different effects of earthquake, ground shaking and different ground settlement, lands and mudslides, solid soil liquefaction and soil lurching and avalanches and displacement and floods, fires, collapses, tsunami, etc. You know all of this. These are the impacts. And tomorrow we'll be discussing about the structure of Earth, and we'll also discuss uh, other chapters also. So I think we will stop here, and tomorrow we will continue from the page number 27. Okay, this is the page number 27 of class NCRT. So from 27 till at least 40-50 we will cover. Okay, so we are going in the speed because this is the revision lecture only, without covering any other aspects. It's purely from the exams perspective, which will come in CDS exam or Afcat exam or ND exam, because this book has been the Bible of geography. Many questions have been asked from this book, the 11th standards NCERT. This book, the physical environment, and another is that is India. So this question, the questions in different exams, not only in NDA but also in UPSC, CSC, that is civil services exams, they have asked couple of questions. So I will suggest you to go through this book. Okay, I think we'll stop it here and we'll continue tomorrow.